Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Abdul Razak. So I would like to introduce our group member. So our group name is Group Maple 2. So program code KCS 1110, course code MAT 183, course group is KCS 110-2F. So this is our group. First one is Nick Muhammad Haikal Hakimi bin Nazrul Azihan. Matric ID is 2021-833-182. So next is Muhammad Naswa Haikal bin Muhammad Termizi. Nombor matric 2021-466-524. So the next our group member is Umar Al Farouk bin Masri, 2021-61-54-56. So the last our group member is me, Muhammad Hafiz bin Razak. Nombor matric 2021-84-1514. So this our group title, application of differentiation.
Assalamualaikum. My name is Muhammad Nusaika bin Muhammad Timizi. My matric number is 2021-466-524. So our topic is application of differentiation. In this topic, sort optimization problem. To solve this, we will use one of the application of differentiation to find the maximum and minimum value from the question. Related problem involve two or more variables that change at the same time, possibly at different rate. If we can find out how all the variables relate, we can know how fast the other variable is changing. This is for the introduction. So the question that we got for group B, it means our group is a rectangular flower garden with an area of 45 meter, is surrounded by a grass border 1 meter wide on two sides and 2 meter wide on the other side, as you can see on the picture. So we're gonna let X and Y be the length and width of the flower garden respectively. So the first question is, we need to express Y in terms of X. So first of all, we can get the area of garden. So the area of garden is Y times length. So SY equal 45. That the area of the garden. So to make it Y in terms of X, so we gonna move to the other side. X to the other side. Y equal 45 per X. So that is Y in terms of X.
Assalamualaikum and hi, my name is Nick from Haikal Hakimi bin Nazrul Azihan and my matrix number is 2120-833 and 182. Okay, here today I will try to solve this question. So as you can see, the question asks about said is a rectangular flower garden with an area of 45 meter is surrounded by a grass border 1 meter wide on two sides and 2 meter wide on the other side. As shown in the figure, let X and Y be the length and the width of the flower garden respectively. So here, my part, I will answer question B. So the question B, the question asks to show that the combined area of the garden and the border is A equal to 2x plus 180 over x plus 53. So here, the answer the question want us to get the exact same answer, just like it stated. So here, first we need to find the total length and total width. So the total length is given, so the total length is 2 plus 2 plus x, and the total width is 1 plus 1 plus y. So here, the combined area of the garden and the border, so now we will use the area formula, that is length plus width. So A equal to 4x plus x multiplied by 2 plus y. So here, to get the equation, we need to substitute the value of y equal to 45 over x into the equation that we just do. So now, A equal to 4 plus x multiplied by 2 plus 45 plus x. So here we need to expand the bracket, and for the second step, we will solve the equation just like we always do. It's just plus and multiply. So here 8 plus 4 multiplied by 45 over x plus 2x plus 40x. After that, we will get 8 plus 180 over x plus 2x plus 45. So here we will bring the 8 at the back to plus, and we will arrange the equation. So that's it for my question and for my answer. Thank you.
Okay, next we will move on to question C. So the question is, what dimension of the garden will minimize the combined area of the border and the garden? So first we know that the area of the garden is 45 equal to xy, and the perimeter of the garden is p equal to 2x plus 2y. So from the area of the garden, we can conclude that y is equal to 45 over x, and we substitute the value of y into the p equation, and we will get p equal to 2y plus 45 over y. We do this to make sure that the equation has only one variable. And next, to find critical value, we need to differentiate p and equal it into 0. So differentiation of p is equal to 2 minus 45 over y square, and from that we will get y equal to plus minus 3 square root 10 over 2. So as we all know, length cannot be less than 0, so y is equal to 3 square root 10 over 2. And to determine the maximum or minimum value, we need to do second derivative of p equal to 0, and the second derivative p is more than 0, so that's mean that it is the minimum value. So we know that p is minimum when y is equal to 3 square root 10 over 2, or 4.74. So from the area equation, we substitute x into the equation, and we will get x equal to 9.49. Hence, the dimension of the garden that will minimize the combined area of the garden and the border is 4.49 times 4.74. That is, x is equal to 9.49 and y is equal to 4.74. Okay, that's all.
Next is question D. Find the minimum combined area of the garden and the border. So they give the function area 2x plus 100 over x plus 53. So to find the critical first we must find the critical value. So we could conclude that first derivative equal to 0. So we differentiate the function 2 minus 118 over x square, so equal to 0. So 2 equal to 100 over x square. So x square equal to 19. So x equal to plus minus 3 times square root 10. Square root 10. So next, we chose the positive one because length cannot be less than 0. So we choose s equal to 3 times square root 10. So to determine the maximum and minimum, we must use second derivative. So negative 2 times 100 x power of negative 3. So we get negative 316 over x cubed. So negative 360 over, we substitute x 3 times square root 10. So we get the second derivative is less than 0. So can conclude that is minimum value. So we substitute x into the first equation. So 2 times 3 times square root 10 plus 118 over 3 times square root 10. So plus 53. So we get 6 times square root 10 plus 16 over square root 10 plus 53. So the final answer we get 90.95 meter. So that's the minimum combined of the area.
So in summary, application of differentiation are important that can make our problem more easier to solve, like to calculate the value based from the question and to check the area of the garden, minimum and maximum value that we can gain from the question. Differentiation also used to calculate the value before we proceed to using derivative method.